last week, it's before. So the weekly pop quiz 2, which was related to MCQs. If you have any question or a doubt, feel free to ask your doubts. You can mention the question number. Question 1, any doubt? Question number 1, any doubt? Question 2 and 3, any doubt? 2, 3, 4. Question 1, okay, there's a doubt. And question 1, the question is, which species is there a lone pair of electron? When we draw CH3, carbon belongs to group 4, so carbon tend to share 4 electrons in the outer shell. So this is having 3 hydrogens, so 1 hydrogen here, 1 hydrogen here, and 1 hydrogen here. So as you can see here, this is having only a free electron is available, but it does not have a pair, like single electron is available only. But when we draw the structure of CH3 with a charge plus, when we say it is plus charge, what does it mean? Electron is being lost. So one of the electron is lost. So one of the electron is lost. This will be the structure of CH3 with a charge plus. And what it shows there are 3 bond pair, but there is no lone pair. This is having a free electron, but not a pair of electron, only single electron is available. When there is CH3 with a charge negative, what does it mean? Like example, carbon is already having 4 electrons, and negative charge means it gain electron, at 1 additional electron. So carbon electron is there, and additional 1 more electron. So what will be the charge? The charge will be negative. So if it is a positive charge, it means it is lost electron. If it's a negative charge, means it has gain electron. So this is actually a methyl radical. Radical means it can be an atom or a molecule which contain an unpaired electron. So this is actually a methyl radical. Then CH3 plus charge means electron is being lost. So carbon is having 4 electrons in the outermost shell. 3 of them it involves like forming a bond with hydrogen, and 1 of the electron being lost. And CH3 negative charge means it gained 1 electron. So that's why there's a lone pair present. So that's why C is the right answer for this. The radical here refers to, like when you have CH3, CH3 means carbon belongs to group 4. Group 4 elements share 4 electrons. But it has 3 hydrogens. So 1 hydrogen here, the second hydrogen here, and the third hydrogen here. So means there is an electron available, but there is unpaired electron. When unpaired electron available on the atom or a molecule, we call them as radical. So this is CH3 radical. Is it clear? No, the term radical means it has only 1 electron available. The term radical means, like example, if I draw the structure of a chlorine bonded with another chlorine. So when the bond will break and each chlorine take their electron back, so this will be the structure. What we call this structure, we call them as radical. Why radical? Because there is a unpaired electron available. So radical can be atoms, radical can be molecules. The term radical means it's an atom or a molecule which contain unpaired electron. There is 1 unpaired electron available. We call them as radicals. Radical is a chemical term which is used for atoms or a molecule with a single electron available for them to bond. That's a chemical term. It's not like any specific topic. It's just a chemical term which is used. Like radicals are there, positive ions or cations are there, negative ions or anions. So same thing we say a radical or a free radical. Question 2, 3 or 4, any doubt? Question 3, okay. Question 2. Under which condition nitrogen behaves most likely an ideal gas? What is the condition for the gas to be an ideal? That it should have a negligible force between the particles. That is one thing. That is a most important postulate of an ideal gas, that the force between the particles or the force between the molecules should be negligible, like no force is there. So under what condition they will have behave like an ideal gas, a nitrogen behave? If we reduce the pressure, if the pressure is low, because what is the relation between pressure and volume? They're inverse. So if the pressure is low, the volume will be high. So the molecules will have large space between them. And when the temperature is high, the molecules move fast, so they will not get time to interact with each other. Because at high temperature, the kinetic energy increases, so the molecules will move so fast, so they don't interact with each other, they don't exert force or attractive or repulsive force on each other. That's the condition. So whenever we want the gas to act like an ideal gas, so what is the condition for gas to be an ideal? The temperature should be high so that the molecules will have a minimum chance of interaction as they will move very fast, and the pressure should be low so that there will be large space between the molecules so they don't interact with each other. No, this is a journal standard for ideal gases. Even if this question I can change, I can say under what condition oxygen behave like an ideal gas, or under what condition chlorine behave like an ideal gas. The conditions remain the same, that the temperature should be high and the pressure should be low. So high temperature and low pressure is a general condition for all the gases to behave like an ideal gas. And what is the meaning of term ideal gas? The ideal gas, the molecules, this is based on the theory that the molecules have very large space between them. The size of the molecule is very small and they don't exert force on each other or interact for a very short time. So under high temperature and low pressure, all the real gases will behave like an ideal gas. Next is question 3. Which equation, the equation for a chemical reaction is shown? All substances in their standard state. Which statement describes a standard enthalpy change of a reaction? Enthalpy change of reaction for this reaction. The enthalpy change when total 1 mole of a product is produced. No, actually not 1 mole of a product is produced. How many moles of a product are produced? Total 7 moles of the product are produced. 1 mole for XeO3 and 6 moles for HF. That's why this statement is not correct. The enthalpy change when total 1 mole of a reactant is reacted, not total 1 mole, when total 4 moles of the reactant reacted, 3 moles of the water and 1 mole of XeF6. So this is not the correct statement. The enthalpy change when a 1 mole of a water is reacted. So according to equation 1, not 1 mole of a water is reacted. How many moles of the water are reacting? Here 3 moles of the water are reacting. So this is also wrong. The enthalpy change when 6 moles of the hydrogen fluoride are produced. That is correct. If you see the equation, 6 moles of the hydrogen fluoride are produced. That's why we select D as a right answer. Because the other 3 statements does not explain the overall reaction. If statement 1 was true, Statement 1 can be true when we say the enthalpy change when total 7 moles of the product are produced, because 1 here and 6. The statement 2 will be correct. The enthalpy change when total 4 moles of the reactant reacted. 3 here plus 1 makes 4. And then the C will be correct. The enthalpy change when not 1 mole, how many moles are there for water reacted? When 3 moles of the water reacts. So we are left with option D as a right answer. Is it clear? So you have to check the equation and accordingly you will answer. Question 4, any doubt? Feel free to ask your doubts. You may have the whole MCQs like this pop quiz as a doubt. You can mention that. It's important that you learn from your mistake, like don't repeat. So just mention the topic or a question in which you have doubt. Question 5, any doubt? Question 5. Molten aluminium chloride has a simple molecular structure. Each molecule consists of 2 aluminium and 6 chlorine. So if you see this, if you draw the structure of aluminium chloride, remember that there's a dative bonding. Sorry. So this is like there will be a dative bonding and chlorine atoms are there. Now, when molten aluminium chloride, which statement is correct? So we have to check the statement or true or the right statement. All chlorine atom in 1 gram of a molten aluminum chloride have the same mass. Why this statement may not be true? Because we have the 2 isotopes of the chlorine. What are the 2 common isotopes of the chlorine? We may have chlorine 35 or we may have chlorine 37. So all the chlorine atoms have the same mass. Why it's not true? Because the chlorine is having 2 isotopes. It can be 35, it can be 37. That's why this statement is not correct. 1 mole of a molten aluminium chloride contains 6.02 exponent 23 atoms. So when you use the ratio, because like Al2Cl6 is there, so it is having 2 aluminium and 6 chlorine atoms. So the ratio is 1:2. So if we have 1 mole means like we have 6.02 exponent 23. So how many moles will be there? X cross multiply. So the answer will be 12 into 10 power 23 moles will be there. So means double. Not if the ratio was 1:1, then 1 mole of aluminum chloride will contain 6.02 exponent 23 atom if the ratio was 1:1. But here the ratio is 1:2. That's why statement B is not correct. What about statement C? 1 mole of molten aluminum chloride contains 3.6 exponent 24 chlorine atom. So when you check the ratio between aluminum chloride and chlorine, the ratio is 1:6. Like 1 mole of aluminum chloride gives 6. So if you have 6.02 exponent 23, then this will be X. When you cross multiply, you will get this answer. What about option D? The empirical formula is Al2Cl6. That is wrong. Why? Because empirical formula is the simplest ratio. So if we have Al2 and Cl6, what is the simplest ratio between 2 and 6? The simplest ratio will be 1 and 3. So the empirical formula should be AlCl3. Is it clear now? Question 6, 7. Okay, question 7. In a sample of a pure water, what is the maximum number that the one molecule of a water, the hydrogen bond can form? So, how to identify this? You have to draw the structure of a water. So, it has oxygen is having two lone pair and two bond pairs are there. So, this lone pair can form a hydrogen bond. That is one possibility. This lone pair can form a hydrogen bond. That is the second possibility. This hydrogen can be attracted towards the lone pair. That is another possibility. And this hydrogen can be attracted towards the lone pair. That is another possibility. So how many maximum number of the hydrogen bond the water molecule can form? So that will be 4. Because hydrogens of the water molecule can be attracted towards the lone pair of another molecule, and the lone pair on the oxygen can attract the hydrogen or form a hydrogen bond. That's why the maximum number of hydrogen bond per molecule will be 4. That's a maximum number. And the number of hydrogen bond formed per molecule changes as we change the state from solid to liquid and from liquid to gas. But that is the maximum number can be 4. Don't the two hydrogen attached to H2O count as then two extra lone pair? Look, if I draw the structure of this, like this is one water molecule, this is a lone pair, and this is a bond pair. Lone pair, bond pair. This is one water molecule. There is another water molecule example here. And another water molecule at this point. Now, if we just check the central water molecule, H2O, so this lone pair attracted towards a hydrogen. So what kind of bond is it? This is a hydrogen bond. That's a 1. This lone pair attracted towards another hydrogen. That is the second hydrogen bond. Then we have another molecule. So this hydrogen attracted towards the lone pair of oxygen. This will be a hydrogen bond. This hydrogen attracted towards the lone pair of another oxygen. That will be hydrogen bond. So if I consider this central atom, how many hydrogen bond maximum it can form? So 1, 2, 3, and 4. That's why option D is the right answer. Is it clear? The intermolecular force. This is the intermolecular force or force between the molecules. Question 8. Hydrated cobalt 2 sulfate loses the water when heated to give anhydrous cobalt 2 sulfate. The water of crystallization is lost to the atmosphere as a steam. 3.10 gram of a hydrated cobalt 2 sulfate is heated to a constant mass. The loss in mass is 1.39. So the mass which is lost is 1.39, means the mass of the steam or the mass of the water which is lost is 1.39. So what you have to do, you have to work out. This is the total mass of the hydrated. This is the mass of the water. How much mass will be there for the cobalt 2 sulfate? So you just take a difference. So we have like cobalt sulfate. dot XH2O. The total mass is 3.10. And we have water molecule. As you can see, it is heated to constant mass. The loss in the mass, like how much mass is being lost, because when you heat a hydrated salt, the mass loss is due to the water only because it will lose a water crystallization. So the loss mass is actually the mass of the water, which is 1.39. So what is the mass of the cobalt sulfate? You will subtract the 3.1 minus 1.39. That will be 1.71. So you have cobalt sulfate and you have water molecule. This is 1.71 and this is 1.39. Then how to solve this question? The same way you divide it by molar mass, you will have to use a periodic table, like divide by the molar mass, then divide by the smallest value, and then just take the simplest ratio. You will get the water of crystallization. So read the question. It's written loss in mass. So when loss in mass is there, it means that's the amount of the water which is given off. If the question was the final mass, like the mass of the content after heating, so it means they give you the mass of anhydrous. Question 9, 10, any doubt? Question 9, 10. Question 10, okay. In question 10, V and Z are both elements in period 3. Each element forms an one stable ion that does not contain any other element. That does not contain another element. The atomic radius is there. Look, first, remember one thing. If we have an atom loses electron. So it will form a positive ion, and the positive ions, the size is always smaller. Why? Because the number of the proton are more than number of electrons, so the attraction increases. And when the attraction increases, it means the size will decrease. And if we have an atom gain electron, what will happen? There are more electrons than protons, so the attraction on each electron will decrease. Like each electron experiences a weaker attraction, so the size will increase. Now we have to check. So V is there, element V is there, the atomic radius is 0.186, and then the atomic radius is 0.095. So what has happened to atomic radius? The atomic radius has decreased. It means what is happening? V has actually lost the electron. Because when atom turn into an ion, the positive ion, its size will decrease. And when you check Z, which is 0.09, but when it form an ionic radius, the size has increased. So if the size has increased, it means it has gained electron. And which type of the substances loses electron? Metal have a tendency to lose electron. And non-metals have the tendency to gain electron. So metal are losing electron, non-metal are gaining electron. So it means this is less electronegative and this is more electronegative. Now, when we check this statement, this is about the question. Now, statement, ions V and Z have the same number of electron shells. That will be wrong. Why? Because when the positive ion is formed, like example, if I say this belongs to period 3. Period 3 means they will have 3 electronic shells. So when this will lose electron, because the metal have a tendency to lose all the valence shell electron. So how many shells will be left for the metal when it will form a positive ion? So it will have only 2 shells left, because what is the tendency of the metal is to lose all the valence shell electron. And so this one is V. What about Z? Z is also initially it's having 3 electron shells. So Z is having 3 electron shells. As a result, what will happen? It will gain electron. When it will gain electron, it will be a negative charge, but it will have three. The number of the electron shells will not change. But for the metals, the number of electron shells will change. It will decrease. So the first statements, ions of V and Z have the same number of full electron shell. That is wrong. Ion of Z are positive charge. That is also wrong. I just explained the reason. They are negatively charged. Z has a greater electronegativity because as we move across the period and we identify that V is a metal and Z is a non-metal. So when we move across the period, what will happen to electronegativity? The electronegativity will increase. So Z is more electronegative than V. And V has more outer electrons than Z. Again, that statement is also incorrect. They will have the full outer shell, like complete the octet, but it will not have, because when Z is forming an ion, it will complete 8 electron, the outer shell. It's a period 3 only. And same thing when V is losing electron, its outer shell now will be the second one, and it will also have 8 electron in the outer shell. So C is the right statement. So when atom form an ion, if it's form a positive ion, the size will decrease. The number of the shell will also decrease. And for negative ions, the size will increase, but the number of the shell remains the same. Question 11, 12, 13. Any doubt? Question 11. Okay. When a chlorine gas is analyzed in a mass spectrum, the ions are detected. Which row is correct? So chlorine atomic number is 17. So 17 minus 35. So what we get 18. So either C can be an answer or D can be an answer. The electronic configuration for plus charge, because like chlorine atom is having 17 protons and 17 electron. But the chloride ion is having 17 protons and 16 electron because it's a plus charge. So we have to write the configuration for 16 electrons. So 16 electron will be 1s2, 2s2, 2p6, 3s2, 3p4. So this one matches with C. So C will be the right answer. So if the charge was written positive, it means it has lost electron. Which statement is correct about the ionization energies? The first ionization energy of a chlorine is more than the first ionization of argon. So what is the general trend of ionization energy? When we move, the general trend of ionization energy, when we move across the period, the ionization energy will increase in general. And when we go down the group, the ionization energy will decrease. And you have to check the periodic table because the position of the elements is important. As they mentioned in the statement that we have a chlorine is there and the argon. So we have chlorine and argon. When we move across the period, the ionization energy increases. So it's written the first ionization of a chlorine is more than argon, which is wrong. We have chlorine here and argon. So means argon should be more than chlorine. That's why this first statement is not correct or incorrect statement. Then the second one, the second ionization of the calcium is more than the second ionization of magnesium. So the trend across the period remains the same. Sorry. So as we go down the group, we have magnesium and we have calcium, Ca. So as we go down the group, the ionization energy decreases. So here it's written the second ionization of calcium is more than second ionization of magnesium. It is wrong. Magnesium should be higher and the calcium should be lower. In C, the second ionization of a sulfur is equals to first ionization of phosphorus. So if we draw the mention the electronic configuration. So sulfur is 16 and phosphorus is 15. The second ionization means like one electron is there which is already being removed and we are removing another electron. That is the second ionization of sulfur. And the first ionization of the phosphorus, we remove the first electron from phosphorus. We call that as a first ionization. Now, how many electrons are there in sulfur? Sulfur is having like 16 protons are there, sulfur atom. And this sulfur ion, how many are there? 15 electrons, I mean. So 16 proton because the atomic number is 16 and 15 protons are there. Here in phosphorus atom is having 15 protons, atomic number is 15, and it is also having 15 electrons. So when you compare there, because here 16 protons are attracting 15 electrons. Here 15 protons are attracting 15 electrons. So means to remove the electron from sulfur, we need more energy as compared to remove electron from phosphorus. So the sulfur first ionization and second ionization should be greater than phosphorus, but it is written it is equal to. That's why this statement is also wrong. Then the 8th ionization of the chlorine is more than the first ionization of a neon. Why it is correct? Like chlorine is there, 7 electrons are already being removed, and we want to remove the 8th electron. So atomic number is 17 for chlorine, and it is having, because 7 electrons are already being removed, so it is 10 electron. And when we talk about the neon, it is having, the atomic number is there, 10. So neon is there, atomic number 10, so it means it has 10 protons and 10 electrons. So here 17 protons are attracting 10 electrons. Here 10 protons are attracting 10 electrons. So it is obvious that this 17 proton will have a much more stronger attraction towards the electron as compared to the 10 protons. That's why the 8th ionization of the chlorine will be higher than the 8th ionization, first ionization energy of a neon. So D will be the right answer. Is it clear, this one? Then we have question 13. Look, about the hybridization, a simple rule of hybridization. Remember one thing, when there's a single bond, when there's a single covalent bond, it is sp3 hybridization. When there's a double bond in the structure, it is sp2 hybridization. When there's a triple bond within the structure, it is sp hybridization. And the term hybridization means when the energy of the orbital becomes same, we call that as a hybridization. So when we check this statement, which statement about the molecule of chlorine, chlorine, nitrogen and oxygen connected with each other is correct? So always remember, when there's a double bond, this is fixed that whenever there's a single bond, it is called sp3 hybridization. Whenever in the structure you find, if there's a double bond, it is sp2, and triple bond, it will be sp. And the term hybridization means the energy of the orbitals are same. So each molecule contain, so whenever a single bond is there, it's always sigma. So this will be say a sigma bond. This will be a sigma bond and this will be a pi bond, or you can change. So each molecule contain 1 sigma and 2 pi. That is wrong. Each molecule contain 2 sigma and 1 pi. It is a non-polar molecule. It cannot be a non-polar molecule. Why? Because two atoms which are having difference in the electronegativity are attached. So two atoms of different electronegativity are there. Like example, nitrogen bonded with oxygen. So Oxygen is more electronegative than nitrogen, so partial negative will be there. And in comparison on this side, and nitrogen is also more, this chlorine is there, because when we move across the period, what will happen? Electronegativity increases. So we have nitrogen is there, oxygen and fluorine. And as we go down the group, the electronegativity decrease, become less electronegative. Fluorine is the most electronegative. So oxygen and nitrogen are more electronegative as compared to that of chlorine. So when the bonds, a linear structure is there between the two atoms which are having a difference in electronegativity, the bonds will not be polar, the bond will be. So it is a non-polar molecule. No, it's not a non-polar molecule. It is a polar molecule. It will be a non-polar molecule if identical groups were attached. Like example, if we were having, say, Be and Cl was 2 chlorine was attached, then this molecule will be a non-polar. Why? Because they overall cancel out each other. The effect. Like this chlorine is attracting electron pair, the other is also attracting. So they overall they cancel out the effect of each other. But in this case, two different atoms are attached on the sides of each side of a nitrogen, and plus the nitrogen is having a lone pair. So it will have a bent structure. So as a result, what will happen? It won't cancel out each other. So this molecule will be a polar molecule, not a non-polar molecule. It is a linear molecule. It cannot be a linear because there's a lone pair present. So with a lone pair, it cannot be linear. From the diagram, and the nitrogen atom is sp2 hybridized. As I mentioned, remember, whenever there's a double bond, it is always sp2 hybridization. And it's not like you recognize this is a sigma. You can also say this as a pi. So the other will be a sigma bond. So whenever there's a double bond, whenever there's a single bond, it is sigma and the hybridization is sp3. When there's a double bond, one of them will be sigma, another one is pi, and the hybridization is sp2. When there's a triple bond, one of them is sigma, two of them are pi, and the hybridization is sp hybridization. Is it clear? There is one bond behind N. Any doubt in this? Pi bond is between the unhybrid orbital. Yes, the pi bonds are, that's right, Imad. The pi bond is in the between the unhybrid orbitals. So less than a minute left. I'll share another link.